Hi. Welcome back to my channel. In the previous video, I demonstrated how to wirelessly control a 6DOF robotic arm from an Android smartphone using MQTT communication. In this video, I showcase a new feature which allows saving the steps of the robot's movement, which can then be executed sequentially. This means that besides controlling the robot from an Android smartphone, you can also create robot movement programs and run them. With this programming feature, the position of each servo in every movement will be saved in an SQLite database within the Android application. We can view the robot's steps displayed in a list. Additionally, we can execute each movement and review it. If any adjustments are needed, we can update the servo position data for that movement, including its speed, whether normal or slow. When the Run All button is pressed, the robot will execute the steps stored in the database sequentially. Now the robot is moving according to the steps in the database, starting from the first step. During the robot's movement, there are slight jerks. Perhaps we need to adjust the delay values to make the movement smoother and not too fast. After reaching the last step, the robot will return to the first step, and this cycle will continue until the stop button is pressed. Upon pressing the stop button, the robot will cease its movement. This is the ESP code used in the project. The ESP needs to connect to both Wi-Fi and the MQTT broker since we're using MQTT for communication with the robot. We've also set delays for normal and slow movements to achieve smooth motion. I've shared this code. Please check the link provided in the video description. This is the Kodular code used to create the Android application. On screen 1, there are several button components used to control each servo. The invisible components used include MQTT extension, TinyDB, JSON to dictionary extension, and orientation sensor. Screen 1 is utilized to manually control servo movements. On the record position page, there are several buttons. One to save the current servo position into the database, another to update the selected data, and a clear database button to delete data. Additionally, there are previous and next buttons to select steps. To execute a step, you can use the Run Current button, and there's a Run All button to execute all steps. This block code is used to save the value of each servo position to the database and execute it. In essence, when the robot is manually moved, it will send the current position of each servo. Kodular receives this message to save the positions by pressing the Add button. The data is then stored in an SQLite database, including its speed. To execute a movement, Kodular sends a JSON message with the command move and the target positions for each servo. When receiving the move command, the ESP will operate each servo according to its target position, and then send back the current servo positions. Let's take another look at when we execute all movements by pressing the Run All button. When the stop button is pressed, the robot will stop at the last movement. And when the Run All button is pressed again, the robot will start moving from the initial movement. In this video, we've successfully demonstrated the wireless control of a 6DOF robot from an Android smartphone using MQTT communication. The showcased features include the ability to record robot movements into an SQLite database via the Kodular app. Users can easily control the robot manually and smoothly execute recorded movements through the provided interface. With the Run All button, users can run all movements sequentially, and the Stop button allows them to halt the movement whenever needed. Overall, this video illustrates how the integration between hardware, ESP, and software, Android app, can provide intuitive and flexible control over the robot. See you in the next video.